So hello everyone, my name is Jessica Lomokso, BSECE 1B. So today, I'm going to discuss about higher order derivatives, implicit differentiation, maxima and minima, and the time rates. So first we have higher order derivatives. Higher order derivatives, it refers to the derivatives of a function taken beyond the first order. The first derivative represents the rate of change of the function, and each subsequent derivatives provides information about the rate of change of the previous derivative. So we have here the given f of x is equals 3 square root of x. So first derivative, f prime of x. To find the first derivative, we can use the power rule for differentiation, which states that for a function of the form f of x equals x raised to n, the derivative is given by f prime of x is equals n times x raised to n minus 1. So applying the power rule to our function f of x is equals x raised to 1 over 3. We have f prime of x is equals 1 over 3 times x raised to 1 over 3 minus 1. So second derivative, we have f double prime of x. To find the second derivative, we differentiate the first derivative obtained in the previous step. Differentiating f prime of x is equals 1 over 3 times x raised to negative 2 over 3. Using the power rule, we get f double prime of x is equals negative 2 over 3 times x raised to negative 2 over 3 minus 1 is equals negative 2 over 3 times x raised to 5 over 3. So the third derivative, f triple prime of x. To find the third derivative, we differentiate the second derivative of obtained in previous step. Differentiating f double prime of x is equals negative 2 over 3 times x raised to 5 over 3. Using the power rule, we get f triple prime of x. We get is equals to 10 over 3 times x raised to 5 over 3 minus 1 is equals 10 over 27 times x raised to negative 8 over 3. So next is the implicit differentiation. Implicit differentiation is a technique used in calculus to find the derivatives of implicitly defined functions. In some cases, functions are given implicitly as equation involving both dependent and independent variables. So we have here the given tangent y is equals cosine x. To start with the given equation, tangent y is equals cosine x. Differentiate both sides of the equation with respect to x. D over dx tangent y is equals d over dx times cosine x. Apply the chain rule on the left side of the equation. Second squared y times dy over dx is equals negative sine x. So divide both sides of the equation by second squared y to isolate dy over dx. So second squared y over second squared y times dy over dx is equals negative sine x over second squared y. Then simplify the left side of the equation. dy over dx is equals negative sine x times cosine squared y. So the final result is dy over dx is equals negative sine x times cosine squared y. So next is the maxima and minima. Maxima and minima refers to the points on a curve where a function achieves its highest maximum or lowest minimum value. These points are critical on optimization problems where the goal is to find the best possible outcome. In calculus, finding maxima and minima often involves setting the derivative of the function equal to zero and solving for critical points. Analyzing the second derivative helps determine whether these points correspond to maxima and minima or point of inflection. So we have the problem here. Find the minimum distance from the point 4 and 2 to the parabola y squared is equals 8x. In the problem defines the distance between a point x and y and another point 4 and 2 in a two-coordinate system using the distance formula. D of equals square root of x minus 4 raised to 2 plus y minus 2 raised to 2. This formula calculates the distance between 2 points using the Pythagorean theorem. We are also given a relationship y squared is equals 8x, which represents a parabolic curve in the coordinate system. To find the minimum distance, we need to differentiate equation 1 with respect to y. This is done to find the critical points where the derivative is equal to 0. We use the chain rule and simplify the expression to obtain d prime is equals to y squared y raised to 2 over 8 minus 4 times 2 raised to y over 8 plus 2 times y negative 2 times 1 over 2 squared of y squared over 8 minus 4 raised to 2 plus y minus 2 squared. Setting the derivative equal to 0, we solve the resulting equation to find the values of y that corresponds to the critical points. In this case, we have 0 is equals y squared over 4 minus 8 times y over 4 plus 2y minus 4 is equals 4 minus y cubed over 16 minus 2y plus 2y minus 4. Simplifying further, we get y cubed is equal 64, which give us the solution y minus y is equals 4. Substituting y is equals 4 into equation 2, y squared is equals 8x. We can solve for x. X is equals 4 squared over 8 equals 2. So finally, we substitute the values x is equals 2 at y is equals 4 into equation 1 to calculate the minimum distance. So this equals square root of 2 minus 4 squared plus 4 minus 2 squared is equals square root of 8 and is equals to 2 square root of 2. So therefore, the minimum distance between the point x and y and the point 4 and 2 is 2 square root of 2 units. So the last is time rates. Time rates is a term that might be used to describe the rates of change of a quantity with respect to time. In calculus, these rates are typically expressed as derivatives. In general, time rates are crucial in describing how quantities evolve over time, and calculus provides the tools to analyze and understand these changes by examining derivatives. So we have here the problem. A balloon is released from the ground 100 meters from an observer. The balloon rises directly upward at the rate of 4 meters per second. How fast is the balloon receding from the observer 10 seconds later? So given the equation s squared is equals 100 squared plus y squared. Differentiate both sides of the equation with respect to time. 2s ds over dt is equals 2y dy over dt. So we arrange the equation to solve for ds over dt. ds over dt is equals y over s dy over dt. So substitute the given values. Time is equals 10 seconds and dy over dt is equals 4 meter per seconds. Substitute y is equals 40 meter into the first equation to find s. So s raised to 2 is equals 100 squared plus 40 squared is equals 11,600. So s is equals square root of 11,600 is equals 107.7 meter. So substitute s is equals 107.7 meter and y is equals 40 meter and dy over dt is equals 40 meter per second into the equation. So ds over dt is equals y over s dy over dt. So ds over dt is equals 40 over 107.7 times 4 is equals 1.49 meter per seconds. So therefore, the rate of change of s at time is equals 10 seconds is approximately 1.49 meter per seconds.